All right, hello, Clayton and Jake. This is 6-6. We are skipping section 6-5. This is the last section of the chapter, last section that we're going to do. Then we're going to start review for this chapter. Possibly take a test over this chapter. We'll see how nice you are. And then we will start your semester project next week. And I'll give you information about that next week. So, 6-6. Okay, we're combining or solving stuff that we normally did as a binomial thing. When we did binomial approximations, we had like an n, a p, a q, and an r. Let's go nrpq. How about that? Write this at the top. nrpq, right? Okay. nrpq, and we use the formula like ncrp to the r, q to the n minus r, right? We did that thing.
Are we gonna need that today?
No, we're not gonna need that today. Okay, so we are solving stuff today using the z-score method rather than using this method. So we're taking information that we would normally do as a binomial using that formula, and we're doing it a different way, right? Okay, doing it a different way. Got it? Normal approximation. Shh. Listen. Normal approximation, we're going to do it the z-score method. Okay, so remember that the z-score method is like x minus x bar divided by the standard deviation. Okay, normal z-score method, x minus x bar divided by the standard deviation. Then you look that value up on a table. Look up on table. We are doing this route rather than this route. Okay, so normal stuff that we would do in a binomial method, we are doing it as a z-score method. Got it? That's the different stuff. Facts. Got it. Okay? All right. This is stuff that we have already written down on our yellow sheet. Okay? That if we don't already have the average. If we don't already have the average, we take n times p, yeah? So if they say like 50% of the class is girls, we would take 50% times the number in the class, so like 14. So 7 girls, right? That would be my average. That's an example of that. So like this would be my P and this would be my N, right? 7. Then the standard deviation, there's actually 12, yeah. The standard deviation would be the square root of NPQ. So if N is 14 and P is 0.5, Q is 0.5, and then we would find the standard deviation that way, right? That would give me my N, my P, Q, all that good stuff, right? Okay, good. That's how we find that information if they don't already give it to us, okay? We know these values, N. Instead of calling it X, we usually call it R. So NRPQ, that's the binomial stuff. And let's go down here, okay? I kind of somewhat lied to you on 6-4 where I said like N has to be greater than 30. Normally it does, but for the purpose of like easier calculations, we went ahead and did them anyway, right? When there was only 27 passengers on a thing. This one, I do know for sure. Mallory, shush. I do know for sure that on your homework assignment, you do need to check these rules. Okay, on your homework assignment, you do need to check those rules because if, and there are some, there's like 1 or 2 problems, if you take n times p, which is finding the average, if your mu is not greater than 5, or n times q, if that is not greater than 5, then you cannot do this problem. Okay? If n times p and n times q, if those are not both greater than 5, then you cannot do this problem and you just move on, right? Okay? For the purpose of small calculations, yes, we violated the 30 rule on whatever day it was, Wednesday. Wednesday we violated the 30 rule, which was fine. They just wanted to make it easier calculations for you. But these ones you do need to check. You do need to check to see if n times p and n times q are greater than 5. If it's not, then you can't do it. Okay? Good? Moving on. Here we go. Go to the backside. Go to the backside, the top of the back. The top of the back. Okay? We're going to talk about this table right here, and you need to listen to this part. You need to listen to this part. Here we go. They're going to ask you for one thing that we have not talked about before. Hush. Shush. Shush. The one thing that we haven't talked about before.
I know she did not say that.
They might say a continuity correction factor. Okay, write this at the top. If they ask for this value, the continuity correction factor. The continuity correction factor. Shush. Shush. The continuity correction factor, they will ask you for this, and I'm going to show you these scenarios, okay, what these will look like. According to, draw some bell curves off to the side over here. So, number 1, it says at least 152, okay? Let's say the average, I don't know, let's say the average is 150. Now, let's go X bar. X bar is 150. I'm just making this up. Let's say X bar is 150, okay? If I'm going 152, 152 would be above average, right? 152 would live here, okay? So here's what we're going to do. X bar would be 150, but if they say at least 152, that means 152 and above, right?
Yes.
So here's how this works. We need to determine what your X is. Normally, X would be 152, but when you're doing a continuity correction factor, Craig, put your phone away.
Okay. I was talking to
When you're doing a continuity correction factor, I'm wanting to do 152 and this direction, right?
Yes.
Okay, so your continuity correction factor wants me to include 152. So what I do is rather than using 152 as my X,
151.
I'm going to use 151.5. You go to the 0.5 on that side of it, whatever side you need. So in that case, our X will be 151.5 instead of 152. And then I do the Z-score from there. So I would do 151.5 minus 150 divided by the standard deviation. Make sense? Okay? And I would figure out what that is, all right?
Why?
The second one,
Why can't we do 152?
Yeah, why?
because we want it to include 152, and if we go from 152 and beyond, it's not inclusive. It's like the open circle thing. It's not including 152 as a value. Does that make sense?
Yeah.
Okay. So this one says more than 152 does not include 152, okay? So this one, 152 is here, and I want more than. I don't want to include 152. So what are you going to use as your correction factor? 152.5. That's what you're going to use for X, okay? More than 152 does not include 152. So I'm going to use that one because we're still going to the right, okay? All right, the next one says at most 152. At most 152 means it includes 152, but I want 152 and below. So if 152 is here and I want it to include 152, which one are you going to use there?
152.
I want it to include.
152.5.
So since I'm going below and I want it to include 152, I'm going to use 152.5 there. Does that make sense? Okay, I want it to include that, all right? The fourth one. Here's my bell curve. Here's where 152 lives. I want fewer than 152, which doesn't include 152. I want here and beyond, so I'm going to use 151.5 as the X, and I'm going to go to the left. Does that make sense? Okay? And then, here's the tricky part. This is the worst part of all. Are you ready for this? When it says exactly 152, here's 152 right here. When it says, this is the hardest one, because when it says exactly 152, what I'm going to do is I'm going to slice it like a piece of bread, right? 152, I'm going to cut this slice, like slice of bread right here, and I'm going to use 151.5 and 152.5. I'm going to do two different Z-scores and find the area in between them. Do you remember how you do that?
No.
You look them up on the chart, you find the percentages, and you subtract them, right? So I would find the Z-score and find the Z-score and find the percent here and find the percent there, and you'd subtract them. But you're doing it like a slice of bread. So when they say exactly a value, you're going to do both of them on either side, 0.5, and then subtract those values. And we'll do an example of that here in a second. Okay? Got it?
Got it.
So that's how that works. All right, here we go. Example 1. Was Mendel wrong? In one of Mendel's famous hybridization experiments. I'm going to draw my own bell curve. They have one down there, but I don't like theirs. Okay? Here's my bell curve, all right? In one of his hybridization experiments, he expected that among 580 offspring peas. Okay, what is 580, by the way?
a number.
N is 580, okay? 145 of them, or 25%, should be yellow. 145 is the, like the R, or in this case, like X, R or X, whatever you want to call it, okay? This is 145, which means P was 25%, okay? Would be yellow, but he actually got 152 P's. Oh, wait a second. 145 is not R.
150. No.
152.
145 is X bar. That's the average. Because we took, or I guess mu in this case. Okay, mu is equal to N times P, right? So they took 0.25 times 580, and they got the 145. So 145 is the average number of yellow offspring peas, okay? 145 is going to go here in the middle, okay? He actually got 152 yellow peas. That is your X value, 152, okay? So 152 is the one above here, right here. This is where 152 lives, okay? Do we see how all this is working out?
Yep.
The average number that it should be is 145, but we actually got 152. So X bar, the average versus what we actually got, okay? Given that N is 580, P is 0.25, okay? We took those and multiplied those together here to get the 145, which is my mu or my average, right? 152 is what we're testing, okay? They want us to find I'm going to write this down below, find the probability of at least 152 yellow peas, okay? All right, so let's talk about what this would be, right? If the average is 145, what's the probability that I get at least 152 in my samples? If the average is 145, what's the chances of me getting greater than 152? I'm looking for like this percent. It's going to be like probably small, right? Probably a small percentage, okay? So we need to decide, we have to do that continuity correction factor. So I'm going to say CCF, your continuity correction factor. Are you going to use 151.5 or 152.5?
151.
We want to do at least. So we want to include the 152. So we're going to use 151.5. Do you see how this works? 151.5, okay? Now I have to calculate the Z-score, okay? Z is X minus X bar divided by the standard deviation.
But we have to find the
Okay, so what is X, by the way?
150.
151.5. We're changing it from 152 to 151.5. Okay, I have to subtract the average, which is 145, and we don't know the standard deviation. Okay, we have to find it. Okay, standard deviation, I call it S, they call it sigma. Okay, which is the square root of NPQ. Okay, the square root of NPQ. Okay, what is N?
580.
580. What's P?
0.25.
0.25. What's Q?
0.75.
0.75. And if I do the square root of all that stuff, it gives me the standard deviation.
Good job.
What you got?
10.43.
10.43. Perfect. Okay, so I'm going to do 10.43. Okay, we're going to calculate the Z-score.
0.62.
0.62. That's the Z-score. Okay, anybody lost what we're doing? X minus X bar, except it's the same as what we were doing before, but instead of using X as 152, we have to use the other number, right? Okay, so 0.62. Then what do we go from here?
What about the chart?
Look up on the chart. Chart. I'm looking for a Z-score of 0.62, and I'm looking it up on the chart. What do you got?
0.7324.
0.7324.
And then minus 1.
Go to 0.6 and over.
Okay, how do you look it up on the chart? 0.7324. Okay, hold on a second.
26.76%.
I got a 0.6 and then what?
6
2. So 0.732.
Chelsea,
So,
did you know
so what this means is that wherever your value was, 73.24% was below him, right? Why does that say below him? Why is that 73.24 below him? I don't want below him. I want above him.
So then you take 1 minus.
You subtract it. Your chart always measures to the left. That's just always the way that it works. Percentiles is whoever's below you, right? 73.24%. And if you subtract that, what do you get?
I just want
26.76. That's not what they got. 26.76. That's what we're going with. Theirs is slightly different than ours. Because they use the full decimal for standard deviation. That's what they did. We rounded ours off as 10.43. Okay? So that's the only difference. That's what they got. So 26.76% is the chances of me getting 152 or more chickpeas that are yellow. Okay? When the average is 145, 150, I don't know what they, I don't know, whatever. Anyway, regular peas, yellow peas. Yellow peas. We're talking about yellow peas.
I love
Okay?
hummus.
So 26.76. Do you see how that works?
Enjoy hummus.
Okay? This is a similar, listen, this is a similar process to what we've been doing all along. We find the Z-score, we find the percent. Listen, find the Z-score, find the percent, but we have to use the decimal form for X. We have to convert that to a different value, okay? All right, here we go. Next one, last one. This is the hard one, so listen. We'll be through it here in like 2 seconds. Here we go. here's my bell curve. Okay, we're using the same information from the example above. So N was 580. P was 0.25. Okay, if I multiply those together, my mu or my x bar was how much?
145.
145. Okay, when we calculated the standard deviation, it was 10.43, something like that. Okay, I'm going to put 145 in the middle. Shh. 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 We want to know the probability of exactly
Slice of bread.
152. You do the slice of bread. So 152 is here.
Shut up, Rachel.
Okay, so what I'm going to do is I'm going to do the slices on either side. 151.5 is going to be one of them, and 152.5. When they say exactly, you have to do a slice of bread, all right? So I'm going to have two different z-scores, z here, and I'm going to have a z here, okay? My first z-score, I use 151.5 minus the average, which is 145, divided by 10.43. The second one is 152.5 minus 145 divided by 10.43, okay?
We already know the first one.
What's the first one?
The z-score, or the percentage is 0.7.
Give me the z-score.
0.62.
0.62. Oh yeah, we did that one. We did that one already. We did that one already.
No, that's right,
0.62.
we know
I'm
it.
sorry. Yeah.
Well,
Okay, what's the z-score for the second one?
0.72.
0.72. Okay, cool. All right, so if this is a z-score of 0.62, z equals 0.62. I'm writing this all out so you can see it. This has a z-score of 0.72. Okay, if I look up 0.62, we just did that one. What percent was below 0.62? 73.24%. Okay, what percent is going to be below 0.72?
0.7642.
0.76.42%. Okay,
Subtract.
so
No,
this
really?
was 73.24%. This was 76.42%. And then I subtract those two. So you get like 3 point something percent.
3.18.
3.18. So the chances of me getting exactly 152 P's that are that much is 3.18%. Okay?
Yes.
Yeah? Got it?
Yeah.
Beautiful. Okay?
Good job,
Now,
guys.
if they
Well
would
done.
have asked us to do this using the binomial, all we would have done is n, cr, p to the r, q to the n minus r. So that seems like that would be a lot less complicated than what we just did, right? But we should get something close to 3.18%.
No, here.
Got it?
Got it.
Got it. Okay. All right. Go through on 6.6 and check to make sure that n times p is greater than or equal to 5 and n times q is greater than or equal to 5. If it doesn't satisfy this requirement,
Not solvable.
not solvable. Okay?
Yep.
Well, we don't have our homework.
Make sure that as you're doing, I know, I'm going to give it to you. Make sure that as you're doing this homework assignment, you are writing out your work. If there is a problem that is like a multi-step, like tons of work to be shown problem and you show nothing, I count it wrong, even if you're right. Because that just means you copied off of somebody. Okay? So make sure you're showing your work on the problems that require it. Okay?
Hey, team.
All right, goodbye, people.